Hello students, welcome to YouTube channel Engineering Mathematics Made Easy for All. This channel is helping lot of students to study at home at any time, anywhere. Yes, I am just helping everyone to clear the subject and study properly. Today we see Gauss Divergence Theorem, which is very important, very easy to identify the problem. In this we study today statement, example, formula, we study everything. Please subscribe to the channel, and if you are interested, if you think that this is helpful, please like the button, very important, and please note down this theorem example in your book and practice the same example again. Please use the calculator, you will get the answer directly. Okay, so here we start today's session, Gauss Divergence Theorem. You see that Gauss Divergence Theorem, if you take let f of x, y, z, so there will be three variable x, y, z, be a vector field continuously differentiable in a solid. Yes, if there is a net flow out of the closed surface, the integral is positive. Yes students, if there is a net flow into the closed surface, the integral is negative. This integral is called flux of f across the surface, dou s. So this is just a introduction of Gauss divergence. So now we see in vector calculus we come across Gauss divergence theorem. It says that Gauss divergence theorem use the connection between the surface to volume integral. Yes friends, we have seen how a volume can be calculated using Gauss divergence theorem. So please keep in your mind, revise this once again. If any doubt is there, just rewind the video once again, you will understand it very easily. Yes friends, so stay tuned to the last end of the video, and if you think that this is easy to understand and it is helpful, please like the button and share it to your friends, and the notes will be given in the description box, and how to use the calculator, integration I've done in calculator, it is also will be mentioned in the description box. Please share it to your friends, and very important, if you like it, please comment in the comment box, so that it will motivate me to make another video and some more important examples I will come with this, and definitely I will be solving the important question from the question paper. Please make it note. So I say that what is the statement friends? Let S be a closed surface enclosed by a volume V, and let f be any differentiable vector function. Yes, then integration of integration, yes, f dot n ds is equal to integration of integration v divergence of f dv is equal to, this is triple integration v del dot f dv. Students, is it clear? So this is a small formula, very easy to remember. Yes, we'll go with the immediately the example students. Please note it down. Please write down, if f bar is equal to 2xyi plus y z square j plus x zk, and s is the rectangular parallelepiped bounded by x is equal to 0, y is equal to 0, z is equal to 0, x is equal to 2, y is equal to 1, z is equal to 3. Evaluate. Yes friends, we can see very easily they have given this as evaluate f bar dot n cap ds. So the examiner students, you see, he is trying to make it the question little bit complicated, so he has not given here divergence theorem. So you can see this double integration f bar dot n cap ds, when you take this in S surface, please note that this is a divergence theorem. So this indicates that this you have to use by using divergence theorem. Is it clear, students? Okay, so immediately we'll simplify this. So now this is solved only by divergence theorem. Okay, now what is divergence theorem says, students? Yes, please remember the formula. Just go back to the video, rewind it once again, and you can see I have already given integration of integration s f bar dot n cap ds is equal to integration of integration v divergence of f bar dv. So this is with respect to volume. Please remember divergence of f bar is equal to, remember the students, del nebula del dot f bar, which is equal to, yes, first to take the formula. Please go to the vector calculus. I have given what is del dot f bar. Del formula I have described. I have also mentioned dot product, and I have also given the f bar formula. So this formula I have already given in the previous video. So I will share the link below this, how to simplify divergence of f bar. Many examples we have done in vector calculus. So please solve this problem, and this will be equal to, students, yes, this is dou upon dou x f1 plus dou upon dou y f2 plus dou upon dou z f3. Is it clear, students? Now in the question they have clearly given that f bar is equal to 2xyi plus y z square j plus x zk. So that implies f1 is equal to 2xy, f2 is equal to y z square, and f3 is equal to x z. So I'll substitute this values in this. Okay, so let me substitute, students. So this will become divergence of f bar is equal to dou upon dou x 2xy plus dou upon dou y y z square plus dou upon dou z x z. Is it clear, students? Okay, so now I have to differentiate. See, this is a vector integral we are doing, but please remember differentiation will be done every time. So you have to participate. Please practice the differentiation. This is a partial differentiation. I'm going to share the video on partial differentiation in the description box. Use partial differentiation. So I'm going to use partial differentiation. Formula. To study partial differentiation, I will just send a link in this description box. Please go to the description box. I am going to upload the notes and videos related to partial differential equation. So using this formula, students, I am going to take this. So here only x is variable, so 2y I will take it outside, it is a constant. So dou x upon dou x will remain, plus similarly in this z square is constant, so I will just take dou y upon dou y, plus here again you can see x is constant, so I'll take out x. I'm going to differentiate dou z upon dou z. So now you can see this is 1, this is 1, and this is 1. Therefore I get the value 2y plus z square plus x. This you can do it directly, students, if you read, study partial differentiation equation. Okay, so here we get divergence of f bar. Please substitute in this formula 1. I will take this equation 1, substitute in equation 1, students. So therefore I say just put in equation 1. So now this is going to become, again they have mentioned already, x, y, z. So here I say that x, differentiation of x, I'll write here, differentiation integration of x is from 0 to 2. Y integration is from 0 to 1, and z integration is from 0 to 3. All this is given in the question, students, directly. Just we have to substitute it. Okay, so now here we are going to integrate this one by one, students. So be alert. Okay, write down the integration now, substitute the value. Here I am going to take integration of integration s f bar dot n cap ds is equal to integration. First, always you are going to take x, then you are going to take y, and then you are going to take z. So all the values I am substituting only in one line. You can see, don't make any mistake, don't give any chance to the examiner to cut your marks. This step is very important. I'll just give the marks distribution. So in the examination point of view, this substitution will be given 2 marks. Please remember this, students. Please substitute here properly. Again I am reminding this. Once again, if you take dx, dy, dz, interchanging anything, substituting the value randomly, making plus or minus, you will lose the mark. So please watch it carefully, substitute properly, and write it down. Very important. So now, so here I am going to simplify this now. This will give you, first I am going to integrate only this part, friends. Please remember, I am going to integrate one by one. Triple integration, don't worry. Don't get afraid of triple integration, students. It is triple means what? One integration you will do, next second integration you will do, then third integration you will do. One by one we do integration, not 3 integration at a time. So not to worry. Only we are going to substitute the integration 1, second, and then third. First I will take the z. So here please remember, only the z is the variable, x and y is going to become constant. So therefore, if constant is there, please consider constant as 1. So when it is with respect to z, integration will give you z. Okay, so now I will take the integration now, friends. Integration x 0 to 2, integration y 0 to 1. Now I am going to integrate this. So in the first, you can see this is 2 y's there. So z is missing. So I just take this as 2y. So I say 2y, integration of 1 into dz will give you 2yz. So I take this as 2yz plus, and integration of z square with respect to z will give you z cube divided by 3. So they are all different formulas I am using in this one equation. So this is z cube divided by 3, and please see here x is there. So take x outside, integration of 1 dz will give you xz. So I am going to take plus xz, dy dx as it is, no change in dy and dx. Okay, so now we'll simplify this, friends. So this is equal to, yes, upper limit and lower limit, don't forget, 0 to 3. So just substitute wherever z is there, 3 I am going to put. So this will become x is equal to 0 to 2, integration y 0 to 1. Yes, when z is 3, so 3 into 2 is 6y. So I'm going to substitute here z is equal to 3, that implies this 2 into 3 into y you will get, or I just take this as 6y. So I just substitute here 6y directly, plus now this is z cube is there, means z cube, I am going to take 3 cube, which is equal to 27. So 27 divided by 3, so 3 ones are 3 nines are, so directly I will take here 9. Yes students, if you are getting confused, please rewind the video once again. This is z, x, z is there, just put z is equal to 3, this is going to be 3x, then dy dx is remaining. Yes students. Okay, so now next I am going to integrate with respect to y. Yes students, very simple. You can see I have just taken first z integration, now I am going to take y integration. Yes students, so this is step by step integration. We say triple integration is very easy. One by one I am going to simplify this. This is equal to integration x 0 to 2, so you should be speed up now. So integration of 6y, so 6 is constant, so I'll take out 6 outside. Integration of y with respect to y will become 6y square upon 2, 2 1s are 2 2s are, so this 2 3s are, sorry, so this is going to become 3y square. So I will write directly 3y square, plus 9 is there, constant is there, so means I will take 9 outside. Integration of 1, nothing is there, means constant 1 I will take, so this way is going to become 9y, so I will take 9y, plus 3x is again constant. Friends, I am writing on the right hand side, you can just watch it. 3x is again a constant, so I take integration of 1 dy will give you 3xy, so plus 3xy I am going to take this. But please remember, upper limit and lower limit, please substitute 0 and 1. Yes friends, within 2 minutes we will simplify the problem now, so just watch it carefully. This is equal to, now integration x 0 to 2, no change. I'm going to put wherever y is there 1, so therefore this is 3 plus 9 plus 3x, 0 is 0, so there is no change, so this will be equal to, just simplify this, I will add this 3 plus 9, only I will add this 3 plus 9 will become 12 plus 3x dx. Now I am going to integrate this ones. Now you can see integration of 12, but 12 is constant, so I will take out 12, so it is 1 dx will give you 12x, and integration of 3x, 3 is constant, so I will take out 3 outside. Integration of x dx will be 3x square divided by 2. Okay, so I will substitute this value friends. Integration of 12 is going to give you 12x plus 3x square divided by 2. Please remember, in the limit 0 to 2. So you can put directly in the calculator students. Even you can put this integration x integration in the calculator. Please try it yourself students. Directly you will get the answer 30, or if you substitute here 2, you will get the answer 30 students. Yes students, thank you so much for watching the video. If you think that this is helpful, please like and subscribe friends. I will definitely make another very important videos related to question paper. Yes, thank you so much friends.